everybody. That is an awesome piece of trivia. I also ran into my friend Justin here, who I attended my first ever Arduino workshop with about 6 years ago. And I haven't seen him for almost that amount of time, so it's awesome to see you. Thank you for attending my talk. It is called Refactoring the Dinosaur. I'm truly honored to be able to speak at JSConf EU, so thank you to the organizers. As Ben said, I actually work at Kickstarter as a front-end developer in New York City, and we're a pretty eclectic bunch of people. We tend to always have side projects going on, and I'm always continually inspired by my colleagues. This is the library at Kickstarter. It's actually known as like the quiet space where you can work. However, after hours, it comes alive. We have 4 D&D groups internally that play here, which is awesome. And there's actually a hardware hacking club also that meets here every second Thursday. And that has a grand total of 3 people in it, including myself. But one other person of this hardware hacking club, his name is Zach Dunham. And you probably can't quite tell what he's doing here, but there's actually shrimp in the water. And he's recording the sounds that the shrimp are making, which is amazing. He is a wonderful person. He's an artist. He does a lot of technology outreach for Kickstarter, and he is just fantastic. Recently, he created this Kickstarter project. So people at Kickstarter actually run their own Kickstarters, believe it or not. And it's called the public radio. And it's this idea of radio monogamy. And so if you have one radio station that you really love, this radio is hard-tuned to that radio station. That's all you get. And so there's a volume button, and there's also a switch to turn it on. And I'm not sure whether you can see that I need the video to come up for me for this, but I actually have the radio here. And that's going to form the basis for the case study that I'll be talking about today. And so Zach and his co-partner, Spencer Wright, actually put together this radio from scratch. They designed the board and everything. And one of the reward tiers for their Kickstarter project was to send it as a kit. So someone can actually receive all the parts, including, I think, the mason jar, and they can actually solder it together themselves. And then they're also responsible for flashing the software onto the chip on the board and flashing that radio station property as well so that they can get the radio station they want. And so if you haven't run a Kickstarter project before, it's actually really a huge undertaking. And so they had a lot of logistics to take care of. And at the time, they'd just written a CLI app in order to flash the chip. However, they wanted something a little bit more user-friendly, just in case there were people that weren't used to the terminal. And so I volunteered to write a hardware app for them just because I've done that kind of thing before. And at the time, they had these Python files that they were using for the CLI. And so I ended up just using those Python files, and I used a Python GUI kit. And this is the app that I put together. And I wasn't super proud of it. It worked really well. You put your radio station in, you'd pick the programmer that you're using, which I have a programmer here. As you can see, it's the blue guy right here. And you have to obviously change your band de-emphasis and channel spacing for what country you live in for the radio. And it worked really well. I lurked on the support forums to make sure that no one was having an awful time with it. However, it had some problems. There was some accessibility problems because you couldn't keyboard tab between the fields, and the screen readers couldn't actually read what was going on. And so it was actually kind of hard to use. It's not super good looking, like if I hadn't put that picture on there with like rounded corners, it probably would have looked like some kind of virus that's about to install itself on your computer. And the error management was really difficult because the open source software I was using to actually run the flashing process, it has status codes, but it doesn't actually have anything in depth. You have to regex against like the standard error output just to figure out what was going on. And so a lot of the time, if there was any error, I dumped the log in the app, and it just looked even scarier at that point. And so like I'm a modern lady, I have modern taste in software, and so I thought, we can do better for hardware apps. Like, this is the way that we've written hardware apps for a very long time now. We can do way better than this. For both our end users, but also for developers. Like, developers should have a much nicer time writing these kind of applications. They can be really frustrating to write. And so I actually rewrote the entire app in JavaScript, and this is actually what it looks like. So I'm going to do you a quick demo if the demo gods are nice. I'm just going to bring up the app, and it is very small on this resolution, so I'm actually going to zoom in. All right, this magnificent lion. All right, so this is the new app. So first off, I can actually keyboard tap into it, which is great. I can actually hide away these advanced settings if you don't need them. And it just looks less like a computer virus, in my opinion. So I'm going to turn the radio on, and hopefully you can hear that. Right. And I'm going to change the radio station. Losing my religion, that's great. And I don't need to change any of these right now because it'll work well enough for me to flash it. And so while we had no sort of progress, I also implemented a progress meter. And I'm actually just going to turn this light out so you can see this programmer here actually programming it. And here we go. Please work. All right. New radio station. So I'm just going to turn this off. I feel like this is a much better experience, and I actually had a lot more fun writing it. But there's a lot of complications because this is not really your standard way of writing hardware apps in JavaScript, right? So I want to take you through some of the challenges and how I put this together. So let's go back. All right. So I actually wrote the GUI in NodeJS. So some of you might be wondering, why didn't you use Electron? This is the new hotness. But you have to actually build native modules for use with hardware. A lot of the time it's just the USB interface. And so it's a lot easier to rebuild those to work with NodeJS. So that was the main reason why I went with that. And I also created a brand new from scratch library that will actually drive the flashing process itself. And I'll explain why as we go through. But this is the API that I wanted to be able to use in the first place, and it's not the API that I actually had access to at the time. So I kind of have to go through very briefly what is actually on this, what is in this radio, how does it actually work? And so the main brains of this circuit is the ATtiny45. Now this is a microchip that's put out by Atmel. It's super powerful. I don't know why anyone's not using this for everyday computing. It has 4 kilobytes of program memory. That's amazing. Why would you need more space? It also has 256 bytes of EEPROM. Now, EEPROM stands for electronically erasable programmable read-only memory. Essentially what that means is you can flash a constant to that memory or a couple of constants, and you can save on your 4 kilobytes if you just need to store values that are never going to change, right? So that's actually where the radio station of choice is flashed to, so that you don't have to keep flashing the software over and over each time. And it's actually just €1. You can buy this for €1, and I don't even think that's the bulk price. You could probably get it for less. So that's kind of the brains behind this. And the way that you get this code, or the radio station to actually go onto the device, is we need a translator in between. And so this here is a programmer, which is the middle of the diagram. And I find it really ugly, so I put a rainbow on it to make it look prettier. This is a vector drawing that I did to try and just make this stuff seem more interesting than it is. And so this programmer actually sort of takes the code that's compiled on your computer, which is usually C, and it's able to speak to the chip. And so the programmer is providing you with a USB interface. And then the programmer can take that, and it uses the SPI protocol, which is the serial programming interface protocol, in order to talk to the chip. So it's doing the actual signal sort of bit flipping in order to get that onto the chip. And so this is sort of how you normally have to create your application. You have a GUI. It can be in any language you want, like Python, or even just actual regular C or Objective-C, JavaScript in this case. It takes your user input. It then obviously compiles down, and then it calls the upload process. This upload process is always a child process, and this is something that's really bothered me, and I'll explain why it's a child process. And it actually writes to the chip, and that's really all there is to it. Now, the application that you normally use to upload this, it was written 16 years ago. It's called AVRdude. And I think it's really cool. It's a C executable. It's available for all platforms. It's less than 500 kilobytes, which is really cool. And this is just what everybody has been using since it came out. There's not really any alternatives at this point other than Atmel's IDE. So AVRdude stands for AVR Downloader Uploader. So it's a bit of a backronym. It's very interesting. And AVR is an acronym used for the microchips that Atmel puts out. Atmel have confirmed that AVR has absolutely no meaning whatsoever, so I can't tell you what that stands for. Look on Wikipedia. It was written in C. It is open source, which is amazing. And everybody uses it because, it works really well. It's been around for a long time. It has a lot of traction because of that. And people have added extra programmers and extra chips over time. It has the greatest compatibility. And it's the only thing really out there that has that strength that you can create dynamic apps like this with, right, without having to open an IDE. And so even the Arduino IDE and a lot of Arduino systems use AVRdude under the surface. So if you go into your preferences and turn on logging, you can actually see the AVRdude command running. It does have some limitations, however. It is command line only, which is why I have to spin up a child process every time if I'm doing runtime code. And that can just be a bit of a pain. And it also means sometimes you have to handle like multi-processes or threading because it'll lock up the UI while you're running that. There are no tests in it at all. So it relies on manual testing if anyone pull requests it. And it has this fragmented community where people aren't constantly updating it, mostly because this stuff doesn't really change a lot, in the span of a decade. But also just, it doesn't have the same community feel as JavaScript does, and that's something that disappointed me. People can be a little bit rude in the forums if you're a newbie, and it's been a pretty disappointing experience for me to kind of try to be part of that community. So, creating a Node.js alternative for this piece of software itself was obvious to me. And so this project here with the radio led me down the track of just completely rewriting this thing. And so why? Well, we have a small family of packages kind of mentality, which I really like. Like, why do we have this monolith? People should be able to install the chip support and the programmer support that they want. It has, it's easier to test that way because there's smaller chunks. It has better flexibility for use. So instead of just having it on the command line, you should be able to require it, with a common JS pattern, and then use it, that way, which is the main pain point for me. It's also more accessible. People that are coming in now to learn programming, they're not necessarily learning C anymore. They're learning JavaScript. And so this opens up this kind of world to more people, and it provides an alternative. I'm not looking to replace AVRdude. I just want to provide a different alternative and have a go at seeing what modern principles bring to it. And I also want to publish it for others. I don't want to just write a piece of code for that programmer and that chip. I want to actually be able to have this as a tool that everyone can use. And so I wrote a tool called AVRgirl. It stands for AVR General ISP Programming Tool. I wanted to keep the tradition going. I respect, AVRdude is an amazing tool. I'm not here to say that it's bad in any way. I want to pay homage to it. So, and so you go on your little journey of programming these things, and you think, this is awesome. Why has no one done this before? People have maybe rewritten parts of AVRdude for their own use, but not the whole library. How bad could this be? And while we're on the topic of dinosaurs, I found a lot of mammoths to shave while I was doing this. And so, one popped up immediately, and I thought, that's okay, I can do this. And, before I knew it, they were everywhere. And I'm thinking, this is why people haven't tried to do this before. So whenever you try and look up how to solve this, this is usually what you run into, okay? Or you just run into people who have used the software, but they don't know how it works. And so, this posed quite a challenge or two. So I want to really quickly go over a couple of challenges that I had with this, just so that people can understand the hardware world a little more. I'm a little lonely in this world. I want to share my pain. So challenge number 1, support USB programmers. So this programmer here is the AVR ISP Mark II, and it runs via USB. And there are a lot of other programmers that run via parallel port and all sorts of crazy stuff. But I just sort of want to support some of the modern stuff to begin with and see if there's demand beyond there. So here is an example of 4 different programmers. We have the AVR ISP Mark II, we have the SparkFun Tiny programmer, we have the SparkFun Pocket programmer, and then we have the AVRdude USB Tiny ISP programmer. And so these programmers are great, and the reason why there's a lot of them is they all kind of have different advantages to them. The problem with that is that they all speak different languages, okay? So in the web world, we have HTTP protocol, we have MQTT, HTTPS, It's no different in hardware. We also have lots of communication protocols that we need to support. And so far, while writing AVRgirl, I've come across these protocols in particular. I don't have time to go into them in detail now, but I have blogged about a couple of them. So we have SDK 500 version 1, which is by Atmel. Then they came out with the version 2, which is actually quite different. We have AVR 109 and USB Tiny ISP, which was actually written by Lamore Freed from AVRdude, which is really cool. And so there was actually a node module for each of these in NPM, which is awesome. And that was Ryan Day, Elijah Insua, Jacob Rosenthal. And a lot of these modules were, as I said before, written specifically for a use case, and they weren't really super generic. And so I had to pull request some of them, and some of them I've just had to rewrite from scratch, because I would basically be rewriting the whole thing. Some of them were feature incomplete as well, which is also why I pull requested them. So I learned a lot about how hardware talks to devices, and then how computers talk to programmers. It was actually really cool. And so I got all of this information from datasheets. And this is kind of how it feels when you first read a datasheet. You're like, oh my, what is this? And so this is an example of a datasheet for a previous library I wrote to drive OLED screens. And after a while, the things start swimming into place where they make sense. But that's a lot of the time all you have, because Google's not going to give you a lot of information. But we got there in the end. I have some protocols that are now supported. All of the Arduinos can be flashed with this software, and this programmer here also has support right now. So challenge number 2. I have to somehow support all of these Atmel chips. Okay, so how many can there really be? Well, there's 400 of them. Luckily, not all of them are actually relevant. Some of them are ARM architecture and that sort of thing. I'm just supporting RISC architecture, which is what the Atmel AVR chips are. So that whittled it down to 135. That's fine, it's great. And so this configuration sits in not a format that I'm used to. I wanted it to look like this, and this is not the entire kind of JSON object of configurations that I created in the end. I had to create my own spec for this. There's about 50 properties. So here's just a snapshot of the kind of properties you need to know, such as the name of it, the timeout. So if it doesn't connect within 200 milliseconds, then it's a timeout, things like that. Really kind of in-depth stuff. But what I had to work with was 200 megabytes of XML files. In order to pull out all of those configurations. And so that was actually particularly time-consuming. But I thought, this has to be done. And I don't want this stuck in XML forever. And so, writing XML translations is really, I wouldn't recommend it. There are a lot of late nights, a lot of crying, a lot of shouting at my significant other when I was in the middle of a bug and he asked me what I wanted for dinner. Sorry, sorry, Eli. But luckily, I have this awesome module. Well, I don't have it, but I used it. It's called XML to JS. I highly recommend using it. It's awesome. Just passes the whole thing. You set up, how flattened you want it, and it was amazing. And so I just had to deal with trying to pull out the random bits of the configuration I wanted, but actually worked out really well. And so I now have 135 chips converted with my spec. Only 5 of them have been tested, so I need more people to test it. Like, I have no idea whether it's actually working. And I don't think I'll actually ever open source the translation file that I wrote because no one's going to ever want to use it, and I'm scared that my job prospects will go down the plug hole after that. But it got done, and I'm actually really excited that I can work with JSON now. So after a while, it just it felt like things were actually kind of moving forward, which is great. So this is sort of how I want the architecture to look eventually. The driver itself is just an NPM module you install, and you get the entire kitchen sink, kind of similar to AVRdude. And so we have our chip config where I'm storing that in a module. So people don't have to use that for AVRgirl. They can use it for anything. The protocols have been implemented as specific modules. So if a programmer is not supported, you can still support the programmer as long as it has that protocol. And then the programmers are just separate wrappers around the protocol with the vendor ID and the product ID and just an easy way to connect with it. But I said before that I want small modules, right? And so I've designed every single package to run by itself standalone so that you don't have to actually buy into the whole AVRgirl thing. You can just use it by itself, and you can just pick and choose what you need. So what have I done so far? Well, I've released 4 packages. I have AVRgirl Arduino, which flashes all of the common Arduinos, which pretty much made use of all of those protocols. I rewrote STK 500 version 2 because I wanted it to have things like writing fuses and writing EEPROM, and the original module was written for the Arduino, and so it also didn't support the USB library that I needed either. AVRgirl chips JSON is the evidence of my tears converting XML to JSON, and AVRgirl ISP Mark II is this programmer here, so you can out-of-the-box interface with any chip with this programmer. And so I'm using AVRgirl ISP Mark II in that public radio app that I showed you. And so again, why? Why go through all of these tiers to create this when AVRgirl AVRdude is perfectly acceptable? Well, I want to provide a better developer experience. I have a lot of empathy for developers because I know what it's like to be one. I want to have really great documentation and have something that feels more native so that they don't feel stupid because they don't know stuff about hardware. This is just a sample from the forums that I talked about. And this person, they're a little curt and they're actually wrong. So, it's not cool. It actually ended up a typo in Atmel's datasheet, and Atmel apologized for it, but it was not what David suggested it was at all. And so, I don't want people to feel like this. It's not okay. And I think as a JavaScript community, we do really good at this stuff. And so, without obscuring what the code is, this is the kind of API you have now. And so you have this awareness that you're entering programming mode, you're writing the EEPROM, and you're exiting programming mode. It just feels more natural. There's a callback in there. We're all comfortable with callbacks. And so, this is kind of what it looks like right now in order to be able to flash the chip. It's 10 lines of code, which is great. And so, to be nice to other developers, you want to have beautiful docs, which I'm trying to write extensively, and I'm also blog posting about it. Ease of use, and it should be implemented in modern tools, modern languages, right? And then let's provide a better user experience for people that buy this crazy Kickstarter kit and have no idea what they're doing. Let's have improved accessibility. The screen reader issue still hasn't been solved in NWJS, but I'm hoping for that. But let's just make it easier for people to be able to use these tools. Let's not make it look like it's a computer virus as well. And hopefully we'll have more uptake in this stuff and a much larger hardware community as a result. And so, this proof of concept, this app here, just taught me so much about what it's like to have to provide for both users and developers and be stuck in the middle. But I feel like I learned a lot about it, and I feel very privileged to be able to work with Zach on this kind of stuff. And I'm excited to hopefully release this as the new official software for the radio, for people who want to change their mind about the radio station. And hopefully people will maybe take AVRgirl and use it for fun stuff, like remotely bricking each other's chips through games online. You know, that would be kind of amazing. And I played this game with somebody at NodeJS EU a couple of weeks ago. It was really fun. So if you'd like to follow progress, I have the master module, which links to all of the others. It's noobcat/AVRgirl on GitHub. If you want to read a blog post, I'm doing lots of blog posts about it. There's like 4 of them right now describing all the different kind of challenges I've met. Thank you for being here for my lessons of JavaScript, lessons, love, and loneliness. And thank you.